Okay, as I mentioned to Jared and Mike, I'll keep an eye on the chat and the QA as it comes in. And we'll try to keep everything up at about 50,000 feet because our audience isn't all that technical generally. And if I see some questions that look pertinent, I'll throw them your way, and we'll just play it by ear and go back and forth that way.
Okay.
Okay. As I mentioned to Jared and Mike, I'll keep an eye on the chat and the QA as it comes in. And we'll try to keep. Okay, we're going to have to kill this sound on the YouTube because it's echoing back through.
Yeah, Deborah, can you mute?
Questions that look pertinent, I'll throw them your way, and we'll just play it by ear and go back and forth that way. Okay.
There we go. Okay, so I'm going to go ahead and start the webinar. That'll let people in, give them a few minutes, and then I'll say start the introduction, and we'll go from there.
Sounds good.
All right.
We've had the opportunity to try on the suits, to sit in the seats, to interact with the display. The emergency egress systems for checking out all the hardware.
Because NASA has not done a flight test program spaceship since the space shuttle. So you're talking late 70s, early 80s, the last time we kind of did this as an agency. So some of it is kind of relearning those techniques and those things that you need to make sure you're watching out for.
We'll be brushing up on all the long-duration spaceflight tasks that we've trained for over the years, including spacewalking and robotics and all the space station systems.
And then we're going to learn all about the new vehicle, all about our suits, how we're going to operate in that vehicle, emergency procedures.
You're going to have kind of this hybrid, if you will, for these first flights where you're helping develop things and at the same time you're getting training. We're going to be building what it is the crew member needs to know.
Things that are really neat to me that are news is putting on a new spaceship and putting your arms into it and actually getting to touch the screens, just like you did as an operator when you're going into space. So those skills that we learned in test pilot school and then later on as test pilots, I think they're going to be put to use in flying these vehicles. It's a new set of hardware you need to do some stuff.
Hello, everyone, and thank you for joining us today. I'm Courtney McLaren, Event and Alumni Relations Coordinator for the Department of Aerospace Engineering. I love how Doug Hurley ended that by acknowledging the team of engineers that it takes to make this happen. We have a few of those team members on with us today, and we will get to talk with them in just a few minutes. Before we do that, though, I wanted to just go over a few things about the webinar here. If you've never been in a Zoom webinar before, you should be able to see the panelists, but you will not be able to see the other attendees. If you want to give us a shout out in the chat box, that's open. Let us know where you're connecting from. We'd love to hear from you. You can also put general comments in there. If you have questions for our panelists, though, we want those to go in the Q&A box. That is where we will monitor questions to ask our panelists. If there's a question that someone asked and you like it, you can give it the thumbs up to let us know how many people want to hear the answer to that question, and that'll help us prioritize which questions get asked. So right now I want to welcome Doug Litteken. Doug is the president of the Houston Illini Club, and he was instrumental in making this happen tonight. Doug actually reached out to me about hosting a joint event. And so Doug, I want to thank you for all your efforts in making tonight happen.
Yeah, thanks, Courtney. And so on behalf of the Houston Illini Club, I just wanted to thank everybody for tuning in. We are the official Illini Club of the Houston area, and we have over 3,000 alumni in the area. And we're extremely proud of each and every one of them. But today we're especially proud of Mike Hopkins and all of the NASA, SpaceX, and contractor community that have helped put this launch together. So thanks, Courtney.
Great, thank you, Doug. And now I'm going to introduce Professor Michael Limbeck. Many of you may know him if you're part of the aerospace engineering family. Michael received all 3 degrees from the Department of Aerospace Engineering, and then worked at NASA for, I believe it was 27 years, and was instrumental in the implementation of the Commercial Crew program. So thank you, Professor Limbeck, for being with us again today and for hosting, or for being our moderator for this event.
Thanks, Courtney, and good evening, everybody. Welcome from wherever you're dialing in from. You're hearing right here from my little basement, where I've been situated for the past 9 months or so, as I'm sure all of you have with COVID around. But tonight we have an opportunity to get together and celebrate one of our alumnus, Mike Hopkins, who's going to take a nice ride into space. And with us tonight, we have 3 panelists who have some familiarity with the trip into space. And I'd like to introduce them and maybe have them tell you a little bit about their backgrounds as we go around the horn. So let's start with Michael Berghart. Michael, good evening and welcome.
Good evening, Mike. Thanks for having me here. Glad to be here. Let's see, for those who don't know me, which is probably most people on, graduated in 1985 and went to work for Rockwell, initially on the B-1 program, and had the opportunity to switch to the Space Shuttle program after that, the unfortunate Challenger accident. As part of that recovery, worked Space Shuttle program for a little over 23 years, starting out as a propulsion and fluids test engineer, and worked my way up through the ranks, and eventually was the orbiter chief engineer for Boeing, and then the orbiter vehicle engineering associate program manager, which had all of the engineers that supported orbiter missions with NASA. And then was fortunate with Mike, we started out the Boeing CST-100 Starliner program, worked on that for a little over 9 years, and this summer took the opportunity to move over and join Blue Origin and bring some of that knowledge and expertise to the New Glenn program, which will hopefully be one of the next new large-scale orbital launch vehicles that'll take cargo and people up to space.
Thanks, Mike. Our next panelist is very familiar with being out in the wind. And no, I don't mean the hurricanes in Houston. But Jared, why don't you tell us a little bit about what you've been doing with NASA?
Sure. So my name is Jared Dahm. I'm the NASA Orion Parachute Subsystem Manager. I grew up in Decatur, went to U of I for aerospace engineering in 2009, actually started as a music performance major and then worked my way over to aerospace. Had internships at Rolls-Royce over in Indianapolis and Northrop Grumman out in California. And then finally got a co-op with NASA So that's where I spent semesters down working here in Houston, then back up to school in Champaign. Finally hired on full-time in 2011. I started off as a GNC analyst, so working with all the flight software systems, guidance, navigation, and control, and eventually made my way into parachutes, where I've spent the last 5 or so years developing, testing, packing, integrating the parachutes for the Orion spacecraft. The NASA team does what we call independent verification and validation of some of these commercial crew program systems. The parachutes are one of them. So we've worked closely with the SpaceX team and the Boeing teams to help them get their parachutes to a safe spot so we can have a nice launch today for Mike.
Thanks, Jared. And last but not least, we've heard from him once, but now let's learn a little bit more about him. Doug, why don't you tell us a little bit about the work you've been doing down there?
Sure, yeah. So my story is similar to Jared's. I'm from a small town in Illinois called Breeze, and I went to Illinois for undergrad and then also for my master's degree. Both those degrees were in mechanical engineering. And then I got a co-op position at the Johnson Space Center in Houston. And so I started working there, I think around 2009, and then transferred over to a full-time employee when I graduated. And so I work in the structural engineering division, which most would say is the most important division and the most important part of the spacecraft. And so we work primarily on the habitable structure. So for Orion, I'm the subsystem manager for the crew cabin structure, which is the primary pressure vessel of the structure. And then I also work on inflatable habitats, which is kind of a new soft goods structure that we're going to be using for long-term missions for the moon and beyond.
Great, thanks, Doug, and appreciate the Illini Club. I know Mike and I went to a couple of events when we were down there in Houston and really enjoyed the efforts you put into it.
Great.
Well, where we sit right now is about 18 minutes to launch. The program started about 4 hours ago with Mike Hopkins and his fellow astronauts for Crew-1 getting into their spacesuits. Actually, it started back around noon when they had their first their lunch. Then they proceeded to get into their spacesuits, hop into their Teslas, and get out to the launch pad. They successfully got stitched into their seats. And when it came time to close the hood on the vehicle, unfortunately, there was a little piece of lint on one of the O-rings. And Mike, you have a little familiarity with closing hatches and lint on O-rings, I think. Want to talk about your experience with the shuttle?
Yeah, shuttle was unique in that the vehicle had 2 distinct orientations. One, the horizontal orientation that we processed the vehicle for in the orbiter processing facilities down at Kennedy. And then we go vertical as part of the stacking process in the VAB and roll out. And one of the things we discovered in executing the program was that the hatch rigging would shift slightly due to the change in orientation. So one of the things we implemented as we learned and executed the program was to revalidate the rigging once we went vertical in the VAB before we went out to the pad. But it is very, it's a most spacecraft employ a dual seal system. It's one of NASA's requirements to be fault tolerant. So you have to be very careful with making sure you clean both the seals and the lands on the structure to make so you have a good seal and you have seal for both of the individual seals themselves.
That's great. Well, they managed to get through this little bugaboo today and have since been counting down. Of course, when everyone left the pad, they retracted the arm. That's the access arm that the astronauts walk out on from the elevator that takes them to the top of the pad. They managed to retract the arm away and start to fill the tanks. And currently they are finishing up the filling of the tanks. The vehicle is outgassing somewhat. That's because all of the fuel is cryogenic at super cold temperatures. And as it sits there on the pad, some of it warms up, expands, and is released so as not to overpressurize the tanks. This evening's launch should be spectacular. I know most of us have seen a couple of night launches, and it's something you'll never forget. But as they go down the range tonight, they're heading kind of into the tail end of a hurricane that passed through, and that's why we were delayed from yesterday to today. And as they head downstream, they try to kind of hug the land up the East Coast and over towards the UK. And that's because if there is a problem, they're able to quickly jettison away and land safely nearby. In order to do that, they have a set of parachutes on board. And Jared, I know you're familiar with parachutes. Maybe you could explain a little bit in the unlikely event that this would happen, how things work.
Yeah, sure thing. So the good thing about working on parachutes is you see them every flight, and you hope that it's at the end of the flight when the astronauts are coming back after they've completed their mission. So we're hoping we don't see them today, but in the off chance that we do, it's for a good reason and because we're saving the crew. So right now, it looks like the crew's sitting on the pad on the top of the rocket. Forbid something goes wrong now, but even sitting on the pad, the Crew Dragon has a launch escape system, or in this case, it would be a pad abort, where it lifts the vehicle up to a safe altitude at which we can deploy the parachutes. Now, we can do that throughout the ascent, like you mentioned, coming over to the UK. Once we get to a certain altitude, we can abort to orbit. So in that case, we wouldn't see the parachutes, but if we do on a lower ascent orbit or abort, you would see the first 2 drogue parachutes come out. Now, those are mortar deployed out of literally cannons, and they get fired out in a big fireball. They're maybe 20 feet in diameter when they deploy, and they slow and stabilize the vehicle to a good speed to deploy the main parachutes. For Crew Dragon, you would see 4 main parachutes, each one over 10,000 square feet of material. So you can think of an average house as maybe 2,000 or 3,000 square feet. One of these parachutes could cover, 4 or 5 houses. So we're talking really big parachutes, lots of textiles, but that drag area is what's needed to slow down a vehicle that weighs, 20,000 pounds to a nice, safe speed to splash down in the ocean.
Great, thanks, Jared.
Yep.
And Doug, you've spent a lot of time with the Illini Club. A lot of our members down there in Houston. Maybe you can speak for them tonight. We've had several younger members in the audience here are wondering, what do you have to study? How do you get into aerospace engineering and get a job like yours?
Sure. So that's a good question. I think as an engineer, there are certainly a lot of parts to a spacecraft if you would just want to talk about aerospace engineering. So aerospace as a major or as a focus isn't necessarily the only place to go, but it's certainly a good place. So I like to think of it, as the spacecraft, there's multiple components. There's the people who work on avionics and work on electronics, and there's people who write software and they write the code. And so you have computer science, you have electrical engineering, you have mechanical engineering who might build the structure or the aero shell. And then you have aerospace engineering, you might build the heat shield or something that might slow you down. You have thermal engineering, parachutes, all those kind of things. So it's actually a number of different systems, but it's really important, obviously, to focus on math, science, engineering, and all those kind of things. But there's so many aspects of a space mission, even outside of engineering. Obviously, we have communications folks that you watch on NASA TV that are helping broadcast this mission. We have lawyers, we have doctors, we have all kinds, business folks, MBAs, we have a lot of those at NASA as well. So it's really, if you're interested in space and you're interested in science, and obviously you want to focus on those science and engineering areas, if that's what you want to get into. But as someone who's also interested, in other aspects of space, you can certainly kind of go any path you want. And there's a lot of ways to go there, especially now with commercial companies coming on board. There's a lot of different places that you can go and work and be part of the space industry.
Yeah, great. Thanks, Doug. Well, we got about 11 minutes left, so let's talk about the man of the hour. The reason we're all here tonight, Colonel Mike Hopkins, or some of us know him as Hopper, is the call sign that his fellow classmates gave him. He's going to be the Dragon commander tonight. That means he's responsible for the crew and the safety of the flight. He's 51 years old. He's a native of Lebanon, Missouri, although we won't hold that against him tonight, since he did spend some time here in Illinois. We'll give him a little bit of bragging rights, if you will. He has a wife and 2 sons. They were out there this afternoon greeting him at the rope line as he was getting into the Tesla to drive over to the pad. He previously flew in space on Expedition 37 and 38, spent 166 days there. And one of the most unique things he probably did, he can claim as an astronaut, was he helped pass the torch that was brought up on the Dragon and then sent back down for the 2014 Winter Games. So that's kind of a unique thing for the torch to make it all the way across the world and into space and back. He has 2 Air Force Commendation Medals and 4 Achievement Medals from the Air Force. So he's well thought of and is a high-performing individual. He was the team captain of the 1991 University of Illinois football team. So if you read down his resume, you just see all sorts of things that say, hey, this guy's a little different. He's special and he's a really good guy. He got his bachelor's degree in aerospace engineering here while playing football. Imagine that. And got a master's degree from Stanford. He eventually went to the Air Force, did a lot of training there, test pilot school and so forth, and joined the astronaut corps. He was in a class that they called the chumps, but Mike Hopkins is no chump, I can assure you. He enjoys backpacking, camping, skiing, weightlifting, running, hockey, and of course, football. And Mike has been very, very good to us back here at Illinois. He has met our students when we've been down in Houston at the Neutral Buoyancy Lab, testing out some equipment last year for a student group project. Came over, offered a critique and some sound inspirational advice. This year, he sent us some inspirational video back, challenging our students to get ready to come down and take up where he leaves off eventually. And he's just an all-around good guy, and we're really rooting for him today. His co-pilot sitting next to him on his right is Victor Glover. Victor is going to be known as the first African-American to actually fly on and live on the space station. So this is a special day for Victor. He's also a rookie astronaut. He's not been in space before. He's 44 years old, a native of California. His wife and 4 children live back there. It'll be his first time, as I said, in space, but he's no rookie when it comes to getting in an airplane. He just said earlier today, he's flown to 64,000 feet, so he can't wait to get over that bar. He has 3,000 flight hours and more than 40 aircraft. He's flown 400 carrier missions and 24 in combat. Has a general engineering degree from California Polytechnic State, master's in flight test engineering from Edwards Air Force Base, and 2 more master's degrees and another in military operational art and science. So Victor's just a really good guy to have in the right seat, and he'll be prepared for anything that's going on today. Shannon Walker is our mission specialist today. She'll be on the far right in the vehicle, as you see the astronauts in their seats today. She's a mission specialist on Dragon and will be a flight engineer for the ISS Expedition 64 and 65. When she gets to orbit, she will become the next commander of the International Space Station. So she'll be following in the footsteps of Peggy Whitson, who previously commanded and was the first female to command the space station. Shannon is a Houston native. She's married to another astronaut, Andy Thomas. This is her 2nd trip to space and her 2nd spacecraft. She previously flew on the Soyuz for Expedition 24 and 25. She served as the commander of the Nemo 15 undersea exploration vehicle. It's a nice little Aquarius lab that's parked off the coast of Florida. It's the closest thing we have to operating in almost zero gravity in a remote location like the space station. She's been a robotics flight controller for the space shuttle program. She likes cooking, running, and weightlifting. She has a PhD in physics, a master's in science, and a bachelor's degree in physics, all from Rice University. So as they say down there your way, I think, go Owls. A bonus fact, while she was in graduate school, she studied solar wind and how it interacts with Venus's atmosphere. So she really enjoys astronomy, and this job going to space will be just right up her alley. Our final crew person today is Soichi Noguchi. Soichi is 55. He's a Yokohama native. He's married with 3 children, has more than 6 months in space. He flew originally on the space shuttle STS-114 Discovery in 2005, and he became the first Japanese astronaut to perform a spacewalk on the space station. In 2009, he launched on the Russian Soyuz vehicle. And so today, launching on Dragon, this will be his 3rd spaceflight vehicle that he will have flown in. This year, in fact, Soichi just completed his doctorate degree in philosophy in advanced interdisciplinary studies at the University of Tokyo. He's got master's and bachelor's degrees in aeronautical engineering from Tokyo. And he likes jogging, basketball, skiing, camping, and apparently flying in lots of different space vehicles. So we're really pulling for Sochi today as well. About 5 minutes left in the launch. Guys, we always do a lot of stuff up on the space station, operational stuff, test stuff. You know, whoever's not keeping up gets to make sure all the systems are working, clean the toilet and so forth. But we're also doing a lot of science up there. And Mike, you know, on the space shuttle, we also did a lot of scientific experiments and got them ready for the flight. How is going to space really helping us down here on the ground?
Well, I can't mention the number of things that have been developed. Most of your cell phones and the small electronics today that you use and take for granted and everything today, you know, were developed and miniaturized as part of the push to for Apollo program to go to the moon. You know, a lot of materials, especially heat resistant materials like Corning, glasses and that were all developed to support the space program. So the space program does a tremendous job of pushing new technologies that then find their way into everyday products we all use and don't even think about today.
That's great. Thanks, Mike. And Jared, I imagine these kinds of flights, you like to see a lot of different things tested as well. The parachutes, for instance, that are working here, a lot of those technologies are eventually going to be used on Mars. And in about 100 days, we're landing on Mars with another rover. Can you speak a little bit about how what we learn here on Earth translates to going further out?
Absolutely. So obviously, the Earth's atmosphere is a lot closer to us than the Martian atmosphere. So it's easier for us to learn here than way out there at Mars. There are a lot of differences, though. So the Martian atmosphere is much less dense than the Earth's atmosphere. So out in Mars, we have to use a combination of entry, descent, and landing techniques. So here on Earth, maybe just our heat shield and our parachutes will cut it to get our astronauts home safely. But up at Mars, to get humans or robots to the surface, it's going to take a lot more. It's going to take retro propulsion, as you've seen on previous landers, and other landing techniques to get us through that thin Martian atmosphere.
Great, thanks. And Doug, you have a fan on the chat who is asking a very specific question. So I think this might be a test, just giving you fair warning. How much can external radiation be blocked in the capsule in the living environment with the structures that you've worked on, like for Orion?
Oh, it does sound like a test. So it depends on the environment that you're in. You know, within low Earth orbit, we're protected really well by the Earth's magnetic sphere. And so the astronauts on the ISS don't see a lot of the solar radiation that you see coming from the sun. And so it doesn't really matter what the structure is, but you know, you're going to get a little bit of that radiation within that the orbit of the ISS in low Earth orbit, but not a lot after that. So when we go on these long-term missions with Orion and beyond, when we go to the moon and Mars, you're going to see a lot more radiation, and that's one of the biggest risks that we have to the crew. And so the structures that we use right now are usually metallic structure. They're very thin-walled metallic pressure vessels. They do not protect us against radiation. In fact, they actually cause secondary radiation. When those particles hit that metallic wall, it creates additional radiation that can hurt the crew. And so we use other things, high hydrogen content materials to protect us from that radiation. And so we would ideally just package the walls of the structure with water or with some high hydrogen content like food to protect the crew. And so the structure themselves don't. But I will go ahead real quick and plug inflatable structures, because they're soft grid structures like I work on. They actually give you better radiation protection than the metallic structure because you don't have that secondary effect from radiation hitting the metallic wall.
Great. Thanks, Doug. Well, we've got just a little over a minute left. We still have a little bit of a block in the screen there, Courtney, in the center of the screen, but you may have your chat back. There we go. On this flight, there will be
50 seconds now until liftoff.
Done on orbit. There's
Yes,
a
you
plant
heard us
habitat
right
module
here.
that will be growing radishes to make their salads a little more interesting on orbit. There'll be some anti-cancer drugs that will be looked at. There's also going to be a very unique asteroid mining experiment where bacteria are used to extract materials from the asteroid, and they'll demonstrate that technology on the orbit. We're cutting down here under 30 seconds. Should be exciting, should be a nice light of the engines lighting up underneath the rocket. And we'll just listen in here for the final countdown.
7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
And resilience rises. Not even gravity contains humanity when we explore as one for all.
M1 propulsion is nominal.
That's the word we want to hear. Stage 1 propulsion is nominal.
Just 30 seconds into this flying crew on board Dragon and Falcon 9. Stage 1 is preparing to throttle down. This is in preparation for max Q, which is maximum aerodynamic pressure.
Stage 1, throttle down.
There's that call out for throttle down.
Power and telemetry continue to be nominal for the vehicle, now traveling at 262 meters per second.
Falcon 9 is supersonic.
There's that call out. The Falcon 9 is supersonic, and we will be passing through max Q here shortly, the largest structural load during ascent.
Max Q.
There's that call out. That Falcon has passed through max Q.
1 Bravo.
And we've just entered Stage 1 Bravo abort mode. That's going to take them through the end of the first stage burning just before second stage activates off the coast of North Carolina.
Briefing, let's go.
T plus 1 minute and 40 seconds into flight. Dragon and Falcon 9 traveling 709 meters per second. That call that MVAC chill is underway, the Merlin vacuum engine.
Now with the call out of MVAC chillin, similar to what we saw in the first stage Merlin engines, the second stage engine being prepared for its ignition coming up in just over 30 seconds from now. We're a half a minute away from 3 quick events in rapid succession. We're going to get main engine cut off. The 9 Merlin engines will throttle down and then shut down. We're going to get stage separation.
Stage 1, throttle down.
And then ignition of the second stage engine. We've begun the throttle down in preparation for stage separation.
If you're living on the East Coast, you might actually be able to see the rocket traveling up the coast. One time in Washington, D.C., I could actually see a space shuttle.
And you see that stage separation has confirmed. There goes that MVAC engine. Stage 2, Crew-1 is now on their way to the International Space Station.
The little pedals you see deployed on the left-hand side of your screen are on the first stage of the booster. And those pedals are going to help slow the vehicle and control the first stage as it comes down to land so that it can be reused again on the next crew flight.
On the left side, you can't make out much. It's a couple hours after sunset in Florida. But
in just a little bit, you'll see on the left-hand side when the video comes back, the one engine at the center of the vehicle will relight to try to slow the vehicle down and turn it around so that it can come back to land. That is probably the big promise that SpaceX has brought to the aerospace industry, is being able to reuse these launch vehicles, thereby reducing the total cost of access to space.
And we've heard call out Bermuda. That means Bermuda ground station has the signals from the second stage of the Dragon and Falcon 9.
We're still continuing as stage 2 burns to listen for those abort zones. We are now in 2A through 2E to Echo, taking us up over the northern
Right now you can see the second stage engine glowing with the standard red that we have come to see over all these missions. Indicates everything's looking good.
Halfway distance.
Power on the MVAC engine continues to run at 220,000 pounds of thrust in the vacuum of outer space.
Dragon SpaceX trajectory nominal.
And trajectory nominal.
Copy, nominal trajectory.
And we hear the reply from the crew acknowledging we have a nominal trajectory. Dragon made it to the Falcon 9 second stage, heading into the low Earth orbit, where Dragon will then separate and begin its trip the rest of the way to the space station.
We'll be looking for SECO, second stage engine cutoff, coming up at 8 minutes and 48 seconds after launch today. So about 3.5 minutes from now, Dragon and Falcon 9 second stage currently flying 2,979 meters per second.
Now currently the first stage has begun its descent. It is through apogee. It's beginning to come back down, where it coming up in another couple of minutes, we will have the entry burn, where we begin to slow down the first stage.
SpaceX trajectory nominal. Copy, nominal trajectory.
Another call out, another nominal trajectory, just what we love to hear.
That voice you're hearing on board Dragon, that's Commander Mike Hopkins speaking for our 4-person crew as they continue their journey now 6 minutes and 12 seconds after liftoff. Trajectory still nominal.
And Leah, you can see on the indicator altitude, 201 kilometers. We're now beginning to essentially level out and pick up velocity to get us into low Earth orbit. We're a little under 1 minute from the ignition for the entry burn on first stage.
And we're about 2 minutes away.
Dragon SpaceX trajectory nominal. Copy, nominal trajectory.
Great news, now 7 minutes after launch. Second stage engine continues to burn, everything looking good. And we'll see that continue to burn for another 1 minute and about 38 seconds.
Right now on stage 2, the crew's getting about a little more than 2.5 G's of acceleration. First stage preparing to ignite for the entry burn.
Stage 2 FTS is saved.
And now you can see the booster getting ready to touch down.
And we've got ignition of the entry burn, center engine, followed by the other 2 restart engines. First stage now getting ready to re-enter the Earth's atmosphere. This is about a 29-second burn, and it's designed to slow the vehicle way down. We're going to shed about 70% of the velocity of that dropping first stage by the time this landing burn completes. I should say by the time the entry burn completes, which is now over. First stage on target for the drone ship in the Atlantic Ocean. Meanwhile, we're watching second stage getting close to getting into orbit.
That's right, we've got about 30
Stage
seconds
2 internal
more.
guidance.
And now just about 20 seconds more of stage 2 continuing to burn until we see second stage engine cutoff, or SECO. We'll coast for a few minutes afterward to allow the rates and motion to...
Roger, Shannon.
There's that call for Shannon. That's Shannon, Ireland, an abort zone, but it looks like we continue smoothly to orbit today.
MVAC shutdown.
And we've got shutdown of the second stage engine on time.
Dragon SpaceX nominal orb insertion.
Launch escape system is disarmed.
And SpaceX copies.
And Leah, the words we like to hear, a nominal orbit insertion.
That's right, John. Nominal orbit insertion, as we mentioned, stage 2. Oh, looks like some action on stage 1.
And looks like it's going to be another successful landing for SpaceX. So there you can see the vehicle safely on the drone ship that's out at sea. That will come back sometime tomorrow or the next day. The rocket will be cleaned up, tanked up, and used again on a future flight. Pretty exciting. Right now, the ground controllers are keeping an eye on the vehicle. It's just a little bit about halfway up in altitude. It'll go through several burns in order to make it to the space station to catch up with it. I'm told there will be a surprise that we should see here in just a little bit in the crew cabin. Each crew carries their own zero gravity detector, if you will. And I've been told that they're going to release something that'll be floating around that will be unique to this crew. Don't know what it is, but we'll keep our eyes open for it here shortly. Looks like everybody's comfortable in their seats. Mike Hopkins is over there on the right-hand side. He's the second in from the right. Victor Glover is just to his left. Both of them are touching the touch screens to get information about the flight. But rest assured, that's mostly for show. They really don't have much control over the vehicle. The SpaceX ship is fully automated. It can carry cargo without a crew to the space station and has done so several times, proving itself. Here, the astronauts can take over with some manual overrides, but generally speaking, they're along for the ride and just enjoy the view out the window when they get to orbit. You'll also note that on their knees, they all have little what look like pads. Those are Samsung pads bought right out of Best Buy that are used to keep track of different things. And I guess I'm going to make note today of Elon Musk is sitting there in the center screen in the front row in the light blue shirt, long sleeve shirt. I have to say, sitting here in COVIDville, for someone who has just tested positive in the last couple of days, that's pretty irresponsible to be there in the middle of his control center that way. But Elon has his own way of doing things, as we all know. And fortunately, he's been pretty successful at normally what he does. And there you see a successful separation of the Dragon and its service module from the upper stage. That means Dragon is in orbit very successfully. From here, it will use smaller thrusters to accelerate, raise its altitude to about 405 kilometers, where it'll eventually do a rendezvous dance with the space station and dock with it sometime, I believe, tomorrow. So, Doug, what do you think?
I think that was great. Another awesome, beautiful launch. I look forward to more Illini launches in the future.
Very good. I'm with you there. Jared, how about you?
Yeah, that was beautiful. Fortunately, we didn't see the parachutes, but we did get to see the first stage come back, which is truly an unbelievable sight. Seeing that thing land back down on the drone trip, that's amazing.
It is. Every time you see that. And for those of you that are wondering, you know, each of these Falcon rockets costs probably on the order of 90 millions to buy one fresh out of the gate. When they're reused, there's about $350,000 worth of cryogenic gas that's loaded up into it. As Elon has said before, airplanes, if we threw them out every time we use them, it'd be pretty expensive to go do flight travel. By reusing the rockets, we can really bring down the cost of access to space and make it possible to do all of the great stuff that we're doing on the space station and moving on from here to the moon and Mars. Here we are looking over Mike and Victor's shoulders. They're getting some pictures there in the center console of the orbital plot that they're on. I believe the picture to the right was a view of what it looks like going out the nose along the orbital track, so that you can see, you know, that they're on track. Those spacesuits are specially designed. Each one is custom fitted to the astronauts. They were built specifically for this vehicle. The seats have a number of unique pieces to them as well. Kind of like the captain's chair on the Starship Enterprise. There are some handhelds to the side. On that handheld, there are several buttons that allow them to access their comm system. You can see on Mike's hand, he's got a mirror on his right hand there. That allows him to hold it up and look behind him. In the spacesuit, there's not much mobility or agility that you can use to move around. So the mirror is there. So if he needs to look behind him, he can. Looks like they're now going to open up their helmets and take some time and probably get out their spacesuits so they can enjoy the rest of the night, maybe get a little sleep before they make it to the space station. So I guess, Courtney, we could take a quick stab if we have a couple more minutes here at answering some of the questions in the Q&A.
Yeah, I think that'd be fine if our panelists have time to hang on for a little bit.
Okay.
Yep, sure do. Yep.
All right. Well, we'll just, I've tried to answer a couple of them while we were watching the launch in writing, but let's just walk down some of these real quick. What makes today's launch a historic one? Well, I think first it's the first four-person crew to fly in a Dragon, the first African-American to fly to the space station, the second woman to become the commander of the space station, just a whole bunch of unique things, and only the second time that the United States has launched from its own soil back to orbit since the space shuttle retired. Guys, Doug and Jared, I'm going to toss this to both of you. One of our attendees would like to know if there's some advice on internships and how to get them before graduation. What's the best approach for doing that?
Well, I do think internships are very important because engineering in the real world is definitely built on the foundations that you build in the classroom, but it is a little bit different. So I like the question about how to get an internship because I agree that's very important. One way to do it, how I kind of got involved with my first internship was to get a leadership position in an organization at U of I. So I got involved with the AIAA, the American Institute of Aeronautics and Astronautics on campus. We had a student branch. And I got involved with the leadership of that community, which helped me network with local companies and Rolls-Royce in Indianapolis. And building that network really is a good way to kind of get a shoe in to help you find an internship.
Great. Doug, do you have any advice on like what kind of GPA you need in order to be successful out there in the real world?
I mean, you might disagree with me, but from my experience, GPA doesn't seem to matter a lot, at least once you get your foot in the door, you know, unless your GPA is really low. If it's within a, you know, pretty solid range, it doesn't seem to matter in the real world. So I don't think there's a lot to that exactly. But to kind of piggyback off of Jared's answer, I think the other thing to note is that an internship is like a good way to get experience in that industry or in that company. But that doesn't mean that if you get an internship in company A, you have to be in company A for 30 years. Like you can shop around. The internship is your opportunity to shop around, you know, different summers or different semesters that you take off school. It's really important to get that experience, but know that you can get that in multiple places.
Great, thanks. Alexander asks if they continuously accelerate and do they feel a difference when they change engines? And I can answer that one absolutely. The ride uphill was characterized by the previous crew as sort of rough. It's not as massive as the space shuttle, so a lot of the vibrations from the engines are not as damped out because it's just a smaller vehicle. It's kind of like the difference between riding in a Lexus over smooth roads and riding in a Volkswagen Bug. You could tell the difference as to which car you're in. When the rocket lands, the question is, what is the speed that the landing legs are deployed at? And I believe it's under 100 miles an hour. It's one of the very last things they do just before touching down. There's a question about connecting on LinkedIn or social media. I would just point out, do a little advertisement for the Aerospace Engineering Department. For those of you that are thinking about coming to Illinois and have an interest in this sort of thing, come to the Illinois website. You'll find there a lot of information about the professors that are working here, the research topics and areas that they're working on. And that will give you a lot of opportunity to see just what it takes to become an aerospace engineer. Doug, here's one for you. How are astronauts in the space station protected from space radiation?
So on the space station, they're generally not that protected, but they're mostly protected by the Earth's magnetic sphere. And so within a certain altitude of the Earth, we're protected by a magnetic kind of shield that goes around the Earth. And just like us on Earth, we're protected by that same shield. And so the altitude or the orbit of the ISS actually flies mostly under that shield. There's a few times during the year where it goes outside of that and it comes back in. And if there is a large solar particle event or a solar storm or something, and the crew is going to be at risk, they actually they go into their crew compartments, which are more shielded than the rest of the structure. And so inside those crew compartments, there's kind of, they line the walls with plastic sheets and with some, like I said, high hydrogen content that protects them from radiation. So for the most part, the ISS doesn't have a lot of built-in radiation except in those little shields.
Great. Well, here's a question for both of you. Do you have a particular aerospace thought leader that you pay attention to, that you follow the news, social media, or podcasts, and that you respect the most? I think there's one answer for you guys. Maybe it might be different than mine. I think his name starts with Jim.
Yeah, Jim's a great leader. I like to look at the people that I work closely with on a day-to-day basis as some of my leaders, because it's easy to see what some of the big leaders put out on social media, and you can kind of follow their thought process through that. But seeing the day-to-day work of some of my managers and some of the system managers for Orion really gets you into their head and be able to really pick down their thought process to apply to, how I might be thinking in the future. So I like to keep it close to home.
Great. And Doug?
Yeah, that's a tough question. Honestly, a lot of the leaders that I look up to are kind of past leaders. So people like Gene Kranz and the Apollo era heroes, kind of reading about what they did and what they went through during their time is a lot of the leadership skills that I try to take to my job. But I also agree with Jared. Like, there's certainly a lot of leadership that goes on at a low level, whether that's individual engineers or small organizations, and that's really where a lot of at least a lot of the skills that I've learned, even from Gene Kranz at a higher level, they come down to play at that lower level. And so I try to be a leader without, be a leader from within, and try to use that as an example to try to help other people and grow the organization from the bottom up.
Great. There's a question about the service module on the Dragon, and it was probably a little difficult to see because, again, we're flying into darkness tonight. And the question was, it looks pretty empty and detaches pretty early. Actually, it doesn't detach. The Dragon service module stays attached to the capsule. One of its primary purposes is to protect that all-important heat shield that's at the back end of the capsule that's used to re-enter the Earth's atmosphere. On orbit, there's all sorts of little dust particles and debris from other collisions that have taken place previously. It's called micrometeorite non-orbit debris. And so one of the things you want to do is to keep your heat shield from being attacked by that, and keeping the service module attached is one way to do it. This service module actually isn't empty. It's filled with a couple of tons worth of experiments and other things that will be deployed and grabbed on by the space station arm and extracted and put out externally on the space station. So it does carry some cargo in it for external purposes. Let's see. We're getting down here to the end. Well, here's one for Jared. It says, why are parachutes not used to recover the first stage on the Falcon?
Yeah, great question. So parachutes are great because they're relatively light for the amount of work they can do. But the problem is they're very inaccurate. So once you deploy your parachutes, you're at the mercy of the wind. You can see that first stage came down and landed on that drone ship, which is no more than a few hundred square feet, a couple thousand square feet maybe. A parachute wouldn't be able to do that because depending on your wind condition, the wind speed, the wind direction, you might deploy your parachutes at maybe 2,000 or 3,000 feet, and you'll just drift to where you drift. And it's a lot easier to recover and reuse those first stages when they're landed dry on that drone ship than recovering them out of the seawater.
Good. Okay, gentlemen, we're down to 2 last questions. First one is, can we speak to the cancer research that's being conducted at the ISS? I do know that there's an experiment that will carry up what are called biochips. Those are actual replicas of our cells from different parts of our body. Different types of drugs will be applied to those cells to see how safe or toxic the drugs are. And that information is useful back here on the ground. A lot of cells act differently in zero gravity. Bacteria, for instance, tend to be more virulent in zero gravity. So by taking out gravity, we can see how things react differently compared to on the ground. And that tells scientists something about the cell's makeup, its architecture, and how it works. And so maybe we get some better drugs out of it when flying in zero G. And the last question, will NASA's objectives change with Jim Bridenstine when he steps down from NASA? I'm going to twist that a little bit for you two guys and maybe talk a little bit about the future program plans for Artemis. Jared, do you want to start?
Absolutely. So our next launch is Artemis 1, and that's planned for mid to late next year. I was actually out at the Cape a couple weeks ago, buttoning up the parachutes for that vehicle. That'll be unmanned. It'll go out around the moon and then come back home. So that'll be to test out all the systems on Orion, including the heat shield, the parachutes, guidance, navigation, and control, all the similar systems that we have on the Dragon spacecraft. Following that will be Artemis 2. That will be 2 years after the launch of Artemis 1, and that will be the first crewed mission for Orion. And that will take a crew of astronauts, again, around the moon and back home. And then finally, Artemis 3 follows up with our first woman and next man to the surface of the moon.
Great. And Doug, you're working on Orion, which will carry the crew to the gateway and then transfer them to the landers to get down?
That's right. Yeah. So as Jared just mentioned, Orion is the capsule that would sit on top of the SLS rocket for those Artemis missions. And so the crew will sit on top, they'll launch and go to Gateway, and that's where the Orion will dock to. And then the crew would transfer into a human landing system that would take them down to the surface of the moon and then back up to the Gateway.
Great. All right, folks. Any last thoughts? Let's do that in reverse order. Doug?
No, I just, again, I wanted to thank everybody for joining us, and I'm glad we had a really successful launch. You know, the launch is just the first day of the mission. And so these guys are going to be up there for a few months doing their mission and then come back down, and we'll have an exciting, parachute deployment and landing of the Dragon capsule. So thanks everybody again, and go Illini.
Yeah. And Jared?
Yeah, Doug's right. The most exciting part of the mission is the last day. That's where we get to see all the exciting parachutes happen. But yeah, it's great to see this happen. Finally having commercial crew capability here in the U.S. is huge. It's also awesome to hear all the folks online, the young folks looking for some inspiration and planning on how they can get into the STEM field. So it's really exciting because we really do need good engineers in the near future to make these Artemis missions happen. So go Illini.
Great. Well, I want to thank you, Doug and Jared. You were excellent panelists. Mike Burkhardt as well. Unfortunately, Mike had to take off for another event earlier. You guys did a great job. You inspired me to think about the future and where we're going from here. And I wish you all luck in your career, and tell the Houston Illini Club hello for us, and give them a big ILL from us. So thanks much. And thank you all for attending in our audience. I really appreciated the great questions we got tonight. I liked what we're seeing in the chat as well. It's good to see folks getting together and catching up with some old friends as we saw. So with that, Courtney, I'll turn it back to you. Thanks.
Courtney, you're muted.
Always do it once a webinar. So thank you to our panelists and for everyone who helped put this event together. We really appreciate, we had some help from the college in here, and Deborah's been streaming to YouTube Live for us. If you would like to know more about aerospace engineering or the events that we host, I've put our social media channels up. You can find more information on there. We have been approved this spring at some point. We don't have a date yet, but we should be able to chat with Mike Hopkins live while he's on the space station. So go ahead and follow us on one of our most social media channels so you can find out more about that event when we have a date scheduled. And thank you all for joining us tonight. We hope you had a great evening with us. I know we're all excited and really proud to be Illini tonight.